First question, minimum operations to make columns strictly increasing. We're given a matrix M cross N, and we are told that the operation that we can perform is to select any value inside grid and increase it by 1. That will be one operation. So we need to use minimum number of operations to make all columns strictly increasing. Suppose we have something like this. Alright, suppose y is less than equal to x. So to make y greater than x, strictly greater than x, so that will be basically x plus 1, so that I use minimum operations. And the number of operations will be x plus 1 minus y. I can iterate in this column wise direction and do that same thing for all the columns, and that will give me the minimum operations. So initially answer or operations is 0. I will consider I'll consider as a column index instead of row. And similarly J will be row index instead of column. So this will be grid dot size J. If grid Ji is less than equal to previous row, that is J minus 1, same column, in that case increase the answer or operation by this much value, and change the value itself of grid Ji to grid J minus 1I plus 1. And we can return the answer. Just one thing, since we are doing a J minus 1, this should not, we should start from the first row instead of the 0th row. So this should be 1. This will be linear in m cross n time complexity, and space will be constant. Let's move. Second problem, find the lexicographically largest string from box part 1. We're given a word and an integer numFriends. We want to divide word into numFriends number of strings, non-empty, and among those splits, whatever number of possible splits that we have, among those strings, I want to find the lexicographically largest string from the box. What is lexicographically largest string? Suppose this is a string. Suppose DBC is a string. Suppose I had something like DBZC, right? Here, since this starts from Z, no matter whatever character, whatever uh, character there is, if I have a Z, then I don't need to worry about any other character. From Z, I will try to find the maximum length substring that I can form. Suppose I am at this point. From Z, the maximum length character that I can form is 3, right? And how do I find what's the largest that I can form from a particular index? Well, that's basically using a constraint or a formula for this particular problem. That is, whatever the largest substring length that we need to find, if I subtract it from word.length, and this is something that starts from uh, starting starting from index I is equal to uh, the remaining characters. So I'm saying that this particular thing goes to one particular friend. What are the remaining number of friends? Num friends minus one, and that should be equal to this, because at least if this is the largest, as large as it could be, then the remaining friends will get one character. So the number of characters will be remaining will be num friends minus one. So if I take this, rearrange it a little, minus plus one, but this is starting from an index I, right? What if there is no starting from index I, we don't have this many length of characters remaining. We only have little less than this. Then I will take the entire, you know, string after that, right? If I don't have that, I will take entire. So there is a limit that I can do using this. Since this is the largest substring starting from index I, there has to be a limit, word dot length minus I. Whatever is minimum, I will take that. So starting from every character in word, I will find this. And inside a global answer, I will store the lexicographically larger one. Simple. That will be our answer. So I'll iterate once through string. So that will be O of n operation. And we can start coding it up. I will have to, make sure there is a edge case because num friends can be one. In that case, I shouldn't do anything. I should return the entire word. So otherwise I'll have an answer. Let's have it empty initially. Iterate through word. If actually instead of answer I can have I can have A. I'm choosing A because it was not going to affect the answer. And if word of I is a character which is lexicographically larger than answer or even equal, then answer of 0, the first character inside answer. If this is the case, then starting from ith index, I'll find a substring of this particular length, right? As we discussed, let me call this sub answer. This is a potential answer. This is only answer if it's lexicographically larger than answer. So I will get that substring using this substring method from ith index. This is the length I want, and I want only if sub answer is lexicographically greater than answer. Then answer is equal to sub answer. That's it. Let's submit it. 10 complexity O of 1 O of n space complexity O of n in worst case, because string can be in worst case equal to word. Alright, third question, count special subsequences. We are given an array nums and we are told that a special subsequence is basically PQRS. These are the indexes in this order in nums such that value at P into value at R should be equal to value at Q into value at S. And between P and Q, since this is the order PQRS, between PQRS, there should be at least one character. So it shouldn't be consecutive. Alright. We need to return the number of special subsequences in nums. So firstly, the first intuition that comes to our mind is by the fact that nums P and nums Q are consecutive and nums R and nums S are consecutive in the sense that this is the order that we need to find. So if I take nums P and nums Q, the things that are in order, to one side, and nums S and nums R, the thing that is in order on the other side, then I will get nums of P divided by nums of Q should be equal to nums of S divided by nums of R. Now the right half and the left half can be solved separately. This is the advantage of this rearrangement. But nums of P by nums of Q and nums of S by nums of R, this might not be always equal as it is, right? We need to remove all the factors such that it is no more divisible. Only in that case there should be equal. And it's not a good practice to divide it literally and equate the double result of each side, because that might lead to precision errors. It's not a good practice. I think that might pass, but we shouldn't do that. So in our case, we will uh, use a particular function which can take two pairs of numbers or one pair of number and divide a common factor among them, so that it will return a pair of number which is no more divisible, right? So I can iterate through nums from left to right, and I will check. Actually, I'll do a O of n square from left to right. Can we do that? Well, we can do that. 10 to the power 6 is possible, O of n square. So I will choose 1 as nums of P, and then choose 3 or 4 or 3 or 6 or 1. Not till here, but I should leave this much, because 4 elements, because R and S needs to have at least 3 elements or 3 space and 1 space between Q and R, and that's why we need to lose last 4 elements. Only 1 3 is a possible pair, at least in this example. So I'll start from left to right. I will have a map and that map will have a key. Key will be a pair of two integers. These two pairs will be, no more divisible, right? And the value can be indexes, right? These indexes needs to be examined. Why? Because we can have multiple indexes for a particular pair, right? We can have, if a pair is x by y, there can be multiple indexes, 1 comma 3 comma 8 comma 10 11 or something like that, right? These can be the multiple indexes, but for a particular, by the way, for from left to right, if this is a pair, then what is the index I'm going to store? X's index or Y's index? It should be Y's index because uh, I'm going to do the same thing when I go from right to left, and for that I will be storing R's index, and I should always be careful of having the keeping the left or the Q's index and the R's index in order with a space of one, at least one element. So I should select from left to right, I should select Y's index and store that as a value. And they can have multiple indexes, so it should be a vector. On top of that, for a particular Y, there can be multiple X's giving us the same pair, right? So I can have something like 5, 8, 2 times 8. They can be things like that. And the same goes for the right hand side, which can be something like n by n, let's say, from right to left. And we can have their own respective indexes. But I'm not going to store that. Actually, for a pair from left to right, I will have this. I need to sort this because uh, I need to sort this. Why? Because if I don't sort it, this will be out of order. It will be something, it will be something like this. To be anything, right? But if I sort it for all the pairs, for all the keys, if I sort it, then when I'm going from right to left, I can just do a binary search on this particular vector because this is sorted. And I will search for index of m minus 1. I'll do a basically lower bound search of index, lower bound search of index of m minus 1. Why minus 1? Because I want to have a gap between Q and R of at least one element. And I'll do that for all the pairs, and I'll keep increasing my answer. And that will be basically a time complexity of O of n square because I'm doing it for left to right and then right to left. And for every right to left, I'm doing a log n operation, right? So that will be mn, sorry, n square log n time complexity. There is a better answer or better way of doing this without the binaries, without the binary search, but that seems a little unintuitive for me. So I'm going to do this way. This might be longer code, like at least more intuitive, at least for me. So I need to have a map. It cannot be unordered because I'm storing a pair. Value will be vector, and let me get size I will iterate from left to right from 0 till not n, but since after p there needs to be 1, 2, 3, 4, 5, 6. Why I'm counting 2 times for every q, r, and s, because there needs to be a gap in between, right? So at least 6 more characters or 6 more elements needed. This will be basically q, and this will be p actually, not q. This will be q. This will be from I or p plus 2, p less than n minus 4 for same reasons. R and S needs to be there needs to be a space of 4 elements at least, and p plus plus. I'm sorry, this should be q. It's confusing without ing. Okay, let's get the ratio using another function. Why ratio? Because we need to remove all the common factors. So I'll call a function get ratio, which takes nums of p and q, and it will remove all the common factors and return the ratio. So that will return pair of int comma int a comma b. So this will basically remove use all the factors that is possible from 2 till minimum of a comma b, and we'll use this factor multiple times as long as it's possible, as long as a mod I is equal to 0 and a mod b is equal to 0. It's a common factor. Then divide a by I, b by I, I'm sorry, and then return b a comma b. Okay, all right. Then update the dot pushback at the index of q, right? Qth index. Now for every pair, for every key, I should uh, sort the vector of indexes. So let's sort so that we can perform the binary search. Alright. Now let's have an answer. We are going to do the right to left, so we need to have an answer. Every time we will update the answer. So let's have a long and from right to left. So this time S is equal to n minus 1. S is greater than equal to 6 because I need 6 space, and I'm subtracting, so S minus minus. This time this will be R I minus, sorry, S minus 2, and R should be greater than equal to 4. I need 4 character space at the start. not character, but space for elements. Now I'll get the ratio for this one as well using the same function. This time I'll pass nums of s because I need to find nums of s by nums of r. So nums of s, nums of r. This time if the ratio is present inside map, then I will do a binary search in this sorted vector of indexes. I'll search for what index? I'll search for r minus 1 index, a lower bound search of uh, ratio dot begin dot end. What value am I searching? This is the search space. I'm doing a lower bound search of what value? Uh, r minus 1. Why r minus 1? Because I need to have a one element space in between r and q, and in order to get the integer index from iterator, I will do a map ratio dot begin subtract from this, and this will be the index. So this particular index is basically equivalent to the number of elements that we have before this, right? Before this, whatever number of elements we have is our answer. So I need to increment answer with index. That's it. Now we can return answer. This is O of n square. This is O of n square with a log n. So O of n square log n will be the time complexity. This will be O of n square log n again. So we in total O of n square time complexity. Let's see if this works. We have a better solution of O of n square, but this was more intuitive for me. So I did this. Okay, there is some problem. My bad, my bad. A mod I and B mod I. This works. Let's submit it. Okay, let's move to the fourth problem. Count the number of arrays with key matching adjacent elements. We again given n, m, and k, and we need to count the number of good arrays. A good array is basically an array which has a length of n, have all the values between the range 1 to m, both inclusive, and inside have exactly k indexes or k pairs of values or numbers which are having ARR of I minus 1 is equal to ARR of I condition uh, to it, right? So if these three conditions are valid, that is a good array. Basically, we need to find the number of different good arrays that we can form, right? So if we have something like this example, then here a1 and 1 is equal. So this is one time or one pair of values which are equal. So k is equal to 1. Here 2, 1, 2, 2, that is also fine. 2, 1, 1, 2, 2, 1. These are all the ones, all the good arrays that can be formed. So we don't really need to find the a good array as such, but we just need to find the count. This can be, used, solved using permutation combination. Suppose we have something like this. These are the positions. There are n positions because n is the length. The first position can have any value from 1 to m. So it has m choices. Why I'm saying only first position has m choices? We'll see that. First position has m choices. Alright. Remaining, how many positions are left? N minus 1 positions. So among those n minus 1 positions, k of them needs to have a fixed value, right? K of them needs to have a fixed value, as in the previous position's value is going to fix the current k value, but we can have a choice from n minus 1, we can have k different positions. So they can be different combinations. It's basically a selection of n minus 1 c k choices, right? But all of them are going to have same value, so I'm not going to multiply with different choice values because that's only one. The last thing is there are remaining n minus 1 minus k positions. These are the positions left, and these positions should not, since we have exactly k indexes, we already have that exactly k positions. The remaining positions should not have the value equal to the previous positions values. So it has a choice of m minus 1 because values previous to it or after it, right? One of the position that falls inside this must not have a value equal to its previous position's value, and the you know that leaves m minus 1 choices. So for these n minus 1 minus k positions, I have m minus 1 choices. So this is one thing, this is another thing, these are m choices. I just need to multiply this. My answer is going to be n minus 1 c k into m minus 1 to the power into m. This is the answer. Now I need to do a modulo, and we already know that we are going to need binary exponentiation for this particular modulo to find the exponent uh, parameter to it. And what's the formula for nck? N minus 1 factorial, n minus 1 minus r factorial, that is minus k factorial, k factorial. Alright, here we need to convert this using a using a theorem. I don't remember the name of the theorem, but so the theorem is basically a to the power m minus 1 is equivalent to 1 modulo m. So here if I do a to the power m minus 1 into a in to the power minus 1, a inverse, so I multiply a inverse to both sides, LHS and RHS. This gives me this, which I can make it, or you convert it, combine the LHS to be a to the power m minus 2, and this should be equivalent to a to the power or a inverse mod m. I'm doing this because a inverse mod m is something that I have. 1 by k factorial is nothing but k factorial inverse. So here a is k factorial and mod m uh, is the modulo that we need to do, right? So I can use this formula, find a or k factorial to the power m minus 2, and do the same thing for n minus 1 minus k factorial as well using this theorem, and use binary exponentiation for the exponent part, right? So let's create the binary exponentiation first. For that we need a base and exponent. So this is the base, exponent. Let's have a product as our result for this particular function. While exponent is greater than 0, we will keep going. If exponent is equal to, if it's an odd exponent, then I can use just a single exponent, factor from it, and multiply product with base and mod in the process. So I'm going to have something mod integer. If it is not odd, if it is even, then I can just square the base and divide the exponent by 2, right? Square the base, so base into base, mod it in the process, and use the exponent by dividing it by 2. Return the result. So this is the binary exponentiation. Here I need to have a result, initially 1. So let me call this part. So for this part I need a NCK formula, right? For that I can create a function. So firstly I need something like NCK or NCR is a function. I can pass in this function uh, n minus 1 and k as two values. What is n minus 1? N minus 1 is n minus 1, k is k. That's it. This is going to return me something. I can multiply that to my answer. Let's mod it in the process because the overflow chances are a lot here. Then I can use the exponent using the binary exponentiation m minus 1, n minus 1 minus k. M minus 1 comma n minus 1 minus k. Alright, let's mod it in the process as well. All right. And lastly, answer into M because there are M choices for the first position. So answer, actually, let's instead of 1 use M, right? Oh, my bad, I changed from result to answer. All right. So now let's create the NCR function, which is going to return something long. It's going to take N and R, and it's going to return factorial of N, factorial of R. These are some things that I'm going to need. So let's create a factorial for all the values from 1 or 0 or 1 to N, right? So let's create it outside so that I don't need to pass it in the function arguments. Resize it inside. +1, let's do it. And initial values, let's have 1. Let's create the factorials or populate the factorials starting from 2 till n factorials. The spelling is wrong here. Factorials of I is going to be a factorial of I minus 1 into I. Let's do a mod for good luck, and I'm going to use this factorial here of n into. Now I need to use the theorem. So let's use the theorem. Use theorem. All right. I'm going to pass n and sorry, not n. I need to pass factorial of r. Factorials of r. I need to pass factorials of n minus r, right? N minus r. And along with it, I need to pass the other value as well, that is m, which is nothing but mod, right? This is mod, so I don't need to pass it. So use theorem is going to return something long. It's going to have a and that's it, right? Here I am going to return straight away using the binary exponentiation. Here I'm going to pass the base as a. Actually, yeah, a, and the exponent as mod minus 2, right? That's it. Let's mod this value as well for good luck. Or I don't need to mod this actually, since I'm modding it here itself. But here, since I'm multiplying, let's mod it. Let's mod it here as well. All right. I think that's good. Let's see if this works. Okay. Oh, I need to return the result. Let's return the result. Let's see now. Oh, okay. Oh, actually, this should be long. My bad. Let's see now. All right, this works. Uh, so in terms of time complexity, it's going to take. This is going to take O of n time complexity. NCR is going to take, or let's say, binary exponentiation is going to take log mod time complexity. Because I'm passing mod minus to it, so it's basically going to take log exponentiation, which is or log exponent time complexity, which is log mod time complexity. This is going to take log O of A1 log log mod again. So log mod time complexity for NCR as well, and this is log mod. So n plus log n time complexity is going to take. And space complexity wise is of n because we have a factorial vector, and that's the fourth problem. Thanks.